So in the previous videos we were agreeing that DNA is a double helix, and in order to create RNA, which is a single strand, we need to take a copy from the DNA from one of the strands in order to create the RNA, which is a single strand. But which strand we are going to use in going to scan and create the RNA? And the process of actually transcriptions we are going to study in future lessons. For now we are going to study the basic terminology of transcription. So let's take the following DNA. In the following DNA molecule, the components are two strands, and I'm going to do my best to write in a good handwriting, which the first one goes from the 5' end to the 3', and because we agree that they are both anti-parallel to each other, the other one will be 3' to 5'. The 5' to 3' will be called the coding strand. And the one that goes from 3' to 5' will be called the template strand. It is called a template strand because this is our template to create the RNA. The RNA that is being created will be produced from its own 5' to 3'. Because do you remember we said that we can't do phosphodiester bonds from 3 to 5'? We have to create phosphodiester bonds only from the 5' to the 3'. And the RNA, this one is anti-parallel to this one. Therefore, this one will be forced to be the 3' to 5', but the RNA will be 5' to 3'. And you see many different questions in the admission exams, in the IMAT exam and on the BMAT exam, that they give you either the coding or the template strand, and they ask you the complementary strand that can attach to this strand. So let's take this section for example, this part ATGA, adenine, thymine, guanine, adenine. And they are going to ask you, you have a piece of DNA which is adenine, thymine, guanine and adenine when it is called the coding strand. Which RNA this coding strand will produce? So we will have to remember that in order to produce RNA from the coding strand, we will have to first of all find the template strand that is anti-parallel to the coding strand, and then the template strand will be actually transcribed to the RNA because the coding strand won't be transcribed to the RNA directly, only the template strand. And we can also call the coding strand the non-template strand. So the non-template strand will never be able to become RNA because it goes from the 5' to the 3', and we need to create anti-parallel RNA strand from the 3' to the 5'. So it goes from 5' all the way to the 3' when it comes to the actual chemical reactions, the phosphodiester bonds. So we will have to first of all find the coding strand, then to see what is the complementary strand, which is called the template strand, and only then we will be able to find the RNA strand. So the coding strand is 5 to 3', the template is 3 to 5', and the RNA again will be 5 to 3'. And this trick always comes up in different admission exams, so you will have to memorize it by heart and to know that you can go from coding to template to RNA. Another nice trick is to remember that in order to find the RNA from the coding strand, all you need to do is to take this strand and just replace the thymine with uracil, because all you need to find is that because RNA has uracil instead of thymine. And if you think about it, if the coding strand is complementary to the template strand and the template strand is complementary to the RNA strand, therefore the coding strand will be in the exact same sequence as the RNA strand, but with thymine instead of uracil. So I hope this video made sense, and I will see you next time.